All right, let us do some problems from chapter 3 as a review. We'll start with problem set 1. For number 1, we need to find y prime. So y prime is equal to cosine of sine x times cosine of sine x times cosine times 1. For number 3, we are also finding y prime, but we have to follow particular steps. The steps say to take ln on both sides, then use the ln rules from algebra, then take the derivative on both sides, and then solve for y prime. So first we'll take ln on both sides. Now we use the rules. So on the left side, that stays ln y. But on the right side, we'll end up with 1/2 ln x plus x squared times ln e plus 10 times ln of x squared plus 1. Now we can take the derivative on both sides. The derivative of ln y is 1 over y times y prime equals 1/2 times 1 over x plus, well, we know that ln of e is just 1. So this is just x squared by itself. So its derivative is 2x plus 10 times 1 over x squared plus 1 times 2x. So we'll go ahead and simplify, and we have 1 over 2x plus 2x plus 20x over x squared plus 1. Then we can multiply by y on both sides. And we'll end up with y prime equals 1 over 2x plus 2x plus 20x over x squared plus 1 times y. But we remember that y was equal to the square root of x times e to the x squared times quantity x squared plus 1 all to the 10th power. So the last thing we're going to do is replace the y. And there's our final answer. For number 4, we have to find the linear approximation. So let's go ahead and write out the general form of it. And then let's find all of our pieces that we'll need. So a is equal to 2, f of x is equal to ln of x. So f of 2 is just ln of 2. And we like exact values, so we're going to leave it as ln of 2. F prime of x, well, it's the derivative of ln of x. So that's 1 over x times 1, which is just 1 over x. So then f prime of 2 is just 1/2. Now we'll put it all together, and we end up with our linear approximation is equal to ln 2 plus 1/2 times x minus 2. So that means when x is near to, very close to it, the function is approximately ln of 2 plus 1/2 times quantity x minus 2. So I'll write it like this. Ln of x is approximately when x is near 2. For number 5, we're going to also look for y prime, but we're going to use implicit. So remember dy over dx, as a ratio, we can just call it y prime. So anytime I do a derivative of a y term, I'm going to make sure I include y prime. So implicit means to take the derivative on both sides, then solve for y prime. So let's do that. The derivative of y is just 1 times y prime equals, well, the derivative of an e function, the rule is we'll just go ahead and rewrite the e function. Now we're going to multiply by the derivative of the exponent, the power, which is x times y, and that is a product, so we'll make sure to use product rule. So I'll go ahead and keep my first, which is x, times the derivative of y, which is 1 times y prime, plus I'll keep my second, multiplied by the derivative of the first, which is just 1. And then let's clean it up. So I have y prime equals, I'll go ahead and distribute x e to the xy times y prime plus y e to the xy. Now I'm going to get my y prime terms on the same side. So I'll have y prime minus x e to the xy times y prime equals y times e to the xy. On the left side, I have two y prime terms, so I'll go ahead and factor the y prime out. And I have y prime parentheses 1 minus x e to the xy. And then the last thing I'm going to do is go ahead and divide by 1 minus x e to the xy. And we have y prime equals y e to the xy all over 1 minus x e to the xy.